Imagine you are in a grocery store and scan the QR code of your favorite vegetable. Wouldn't it be cool if you can view the details of where it was grown, planed, and processed? What if you can trace the supply and distribution to know the means of transport, how long it took to arrive at the store, and how long it has been there in the store, and so forth? Blockchain technology can help record that information at each step and make that information available to everyone transparently. In fact, Singapore-based Rechain created blockchain-based supply chain to monitor product as they move along from manufacturer to store shelf. Walmart is working with IBM for enhanced tracking and traceability of its food products, resulting in better food safety. Blockchain can be applied to many other applications, especially when it comes to finance. The global money transfer is time-consuming, error-prone, costly, and subjected to money laundering. Blockchain can help solve money transfer issues without any intermediary, which is why you will find a lot of banks investing heavily on blockchain technology. And of course, blockchains are best known for their crucial role in cryptocurrency systems such as Bitcoin, for maintaining a secure and decentralized record of transactions. According to Wikipedia, a blockchain is a distributed database that is used to maintain a continuously growing list of records called blocks. Database and blockchain both can record transactions. However, databases are owned by a central authority, a company or a government institution, which controls access by granting different roles to different users. Whereas a blockchain is a distributed peer-to-peer network, where each node can connect with every other node, and blocks in a chain are connected using secure protocol. Every node in the blockchain network connectively takes part in the consensus algorithm, using proof of work to validate transactions. Now this all sounds nice, but how does it work? Blockchain, as its name implies, is formed by multiple blocks linked together in a chain. At a high level, each block normally contains a data, which could be anything like transactional data. A hash value, this is basically the ID of the block. Previous hash value keeps track of the previous block ID. We use this value to form a chain between the current block and the previous block. A timestamp that tells us when the block was created, and proof of work, which is essentially the number showing the effort to find the hash value of the current block. If you have heard of mining, this value represents how long it takes for the machines to calculate the hash value. Now let's see how it looks in the code. Here, we have a class called block inside an empty JavaScript file. This class constructor accepts two arguments. The first one is the hash value of the previous block, and the second one is the data of the current block. Inside the constructor, we initialize the block data with constructor arguments. We set timestamp to the current time and proof of work to 0. The hash value is not just a random string. We need to find the current hash value based on both current data and previous hash value for security's sake. If a hacker changes the data of a block, they also have to recalculate hash values of all the blocks ahead to make the chain valid. And this might take thousands of years. Hashing is basically how we convert our data into a bunch of random alphanumeric characters. And because hashing only works in one direction, it is easy to find the hash output given the input. But it's super hard to credit the input from the hash output. Here we are using the hash function from priv2js npm package. This package basically allows us to use several hashing methods. In our case, we use SHA-256 in this tutorial. As you can see, we import the hash at the top of the file. And finally, we have the mind function. This mind function keeps increasing proof of work until we found hash starting with desired number of zeros. We also call this as difficulty. The higher difficulty is, the longer it takes for the hash value to be created. This is because the only way to find the input from the hash output is to try different inputs one by one. By the way, the hash value of Bitcoin block requires 18 zeros, which takes about 10 minutes for all the computers in blockchain network to create. If you have heard of people talking about mining crypto, this is how it works under the hood. They invest in super machines to calculate the hash for a new block and receive number of cryptos as reward. Now you might wonder why it has to be that complex. Imagine if creating a hash was simple and fast, data stored in blockchain would be easily changed. Therefore, the hash value is created in such a complex way so that even if a block is hacked, it will take forever to update all the following blocks, and this is why blockchain is so secure. Now let's create our blockchain class. Our blockchain store contains an array called chain. We would also add a genesis block to the chain. Normally, the genesis block is the first block in the chain, and therefore we could pass 0 as the previous hash value as there is no previous block. And next, we will implement our addBlock function, which adds a new block to the chain. The function accepts new data as parameter and creates a new block based on the data and the hash of the previous block. Remember, when we create a new block, we have to calculate its hash value using the mind function. And to make it fast, you're only setting the difficulty to 2, so the new hash value must start with 2 zeros. After finding the hash value, we just need to add the new block to the chain. Finally, we need an isValid function to validate if the current chain is valid or not. The function basically goes through each block except the Genesis one and checks if there is any violation in the hash value. It returns true if there is no violation. And if you have made it so far, congratulations on your first blockchain. Now let's try to add 2 new blocks which contains transactions information to our blockchain. In the first block, we have a transaction of amount $100 from Marty to Wendy. In our second block, we have a transaction from Ruth to Darlene for an amount of $150. Now once we add these 2 values, our blockchain will look like this. If you notice, the previous hash of each block is exactly the same as the hash of the block before it. Imagine Darlene, who is the recipient in the second transaction, wants more money and modifies the block data like this. Bits will make the entire blockchain as invalid because the new hash value of the first block is different from its previously calculated hash. Darlene must recalculate the hash of every block forward to make it valid, which is impossible in real life.